Given the function h of x equals 2x to the fifth minus 3, find the sketch of this new function with transformations, identify the x-intercepts and the y-intercept. Okay, so step 1, we're going to locate the basic function. Well, this function looks a lot like f of x equals x to the fifth power, and x to the fifth power is like a snake that slithers through the origin, but it spends a lot of time in the actual origin area. So we have f of x equals x to the fifth power, and we have the picture here. Let's figure out some ordered pairs. When x is -1, y equals -1 to the fifth power, which is -1. When x is 0, y is 0 to the fifth power, which is 0. And when x is 1, y equals 1 to the fifth power, which is 1. We'll graph those 3 points, but they're the same points that were on x to the third basic function. The difference is this guy kind of takes it more time to slither through the origin 0, 0. So it almost looks flat as it goes through the origin. So this is our picture, very similar to x to the third, but flatter in the center. Okay, step 2, we're going to locate, after we write these points, we're going to locate the variations in our given function, y equals 2x to the fifth minus 3. That's what we were given. There's only 2 variations from our basic function, and that is item A, the multiplication by 2 in the front causes a vertical stretch of our basic picture. It changes the ordered pairs x, y in the basic function to the ordered pair x, comma, 2 times y. That's the change that I'll identify as A. The change B is the 3 that's being subtracted from the back. That causes a shift down 3 units. And the basic ordered pairs x, y in the original function become the ordered pairs x, comma, y minus 3. You subtract 3 from all the y coordinates, so that's variation B. Okay, those are the 2 variations we're going to use to come up with our table in step 3 for our sketch. First, when we start with our basic function, we have the 3 ordered pairs. We'll write those 1, 1, 0, 0, -1, -1. Now, step A tells us that we are to take each of the y coordinates and multiply them by 2. So that changes the 1, 1 to the ordered pair 1, 2. It changes the ordered pair 0, 0 to 0, 0, because when I multiply the 0 by 2, it's still 0. And it changes the last ordered pair, -1, -1, to -1, -2. Finally, step B says make the last variation by subtracting 3 from the y coordinates. We'll do that for each of the ordered pairs in step A. So the first ordered pair in step A was 1, 2. We're going to subtract 3 from the 2, the y coordinate, and we'll get the ordered pair 1, -1. In the second ordered pair, 0, 0, it becomes 0, comma, -3 when we subtract 3. And finally, the ordered pair -1, -2, when we subtract 3 from the y coordinate, becomes -1, -5. And then we're going to identify the x-intercept and graph it, and the y-intercept. To find the x-intercept, we're going to let y equals 0 in the given equation. Okay, the given equation is y equals 2x to the fifth minus 3. So let y equals 0, and then we'll find the x-intercept. When y is equal to 0, we have 0 equals 2x to the fifth minus 3. Solve for x to the fifth, then take the fifth root of both sides, which is x to the fifth equals 3/2. So x equals the fifth power of 3 over 2. And if you run that through your calculator, it's approximately 1.08. So that gives us the x-intercept, ordered pair, 1.08, comma, 0. I needed to estimate that because we're going to put it on the graph. That's why I ran it through the calculator. For the y-intercept, we let x equals 0 in the given function. We get y equals 2 times 0 to the fifth power minus 3, which is just -3. So the y-intercept is 0, comma, -3. Now let's graph our new function. We're going to write our x and y axis, and we're going to graph the points on step B, the 3 points. And we're also going to shift the center. The center is going to be shifted 3 units down from where it originally was. So let's graph the ordered pairs that we have. The ordered pairs, let's see where we're at. Let's write the ordered pair 1, -1, 0, -3, and -1, -5. Okay, those are all on here. Connect them together, and you see how shifting putting the dotted line, essentially shifting what was the origin down 3 units, it makes it easier to do the graph. I mean, that dotted line is not really there, but it just makes it easier to do the graph. Let's make sure that we have our intercepts graphed here. Yes, we do. We have our intercepts at 1.08, 0, and the intercept at 0, -3. Here's 1.080. And let's identify each of the ordered pairs and put a box around our final answer. So that's finding the graph of a new function using transformations.